Welcome friends. Let us begin our learning. I have planned two topics for the initial sessions. Topic number one is energy scenario and topic number two is renewable energy applications. Topic 1, the outline of topic 1, energy and scenario, will be presented in 3 sessions. Those sessions will be as follows. Session 1 will be energy, in which significance of energy and some basics will be covered. And then in second session, we will discuss about coal, oil and natural gas scenario at the world level as well as Indian level. Then session 3rd will be overall scenario. We'll cover overall scenario at the Indian level and energy security concerns over the encountered by India. Significance and basics. What is the significance of energy in the development of civilization? Energy is a basic need of all the living species for survival. Human existence has been dominated by the age-old necessity for energy. Energy and civilizations are inextricably linked. For tens of thousands of years, people relied solely on the chemical energy gained from food in the form of calories. We eat food and then we get energy. This is a chemical form of energy. The caloric energy then produced the mechanical energy which is utilized in the muscles. But human intellect overcame physical limits imposed on their own muscle power by using tools and harnessing the energies outside. The earliest energy consumption focused primarily on the extraction, processing, exchange, and marketing of food. The energy-related activity also involved making of fossil and organic energy sources, such as wood, peat, coal, etc. These energy sources were used for heating, cooking, lighting, and firing the kilns, and furnaces used in smelting ores. Before the modern era, people relied for power on water and wind, sailing of ships, water wheels, and windmills were the technologies used for harnessing these energy resources. The development of the camshaft and crankshaft allowed water power to be applied to tasks that required reciprocating motion, that is, operating trip hammers, blast furnace bellows. These things revolutionized the iron industry. The modern era began with the 18th century introduction of steam power. The steam engine of James Watt displaced geographically inflexible water power machines. So water power machines were inflexible. They had their own limitations. So a synergistic with the development of steam power, a synergistic relationships between coal mining, the iron industry, and steam power. This harmony led to advances in steam technology. So steam technology flourished with the development of steam and its application. Ultimately, steam power proved to be the most flexible and economically efficient choice of industries. A strong link between steam engineering and fossil fuel energy sources such as coal and wood was established. In the first half of 20th century, crude oil, which is also black in color, crude oil was discovered in Southern California in the USA in 1859. The discovery indeed resulted in the development of oil as a fuel for steam generation. Subsequently, crude oil unseated coal as a steam fuel because of its higher calorific value, convenience in handling, and storage and combustion. We all know the utility and importance of crude oil. What we get from crude oil is petrol, diesel, kerosene, and all, and the application range of all these is not necessary to explain. So, oil has occupied our lives. One of the greatest technological challenges after that encountered in the 18th century was transmission of power. Power was produced, but how to transmit it over long distances? Towards the end of 18th century, the phenomena of electricity fascinated the scientists. The production of electricity with electromagnetic induction, the transmission of electricity through copper wires, and the development of electric motors ultimately revolutionized the transmission of power. The shape and character of factories changed dramatically during 20th century as machines powered by electric motors could be sighted almost everywhere. Electricity replaced gas for outdoor lighting, and it replaced kerosene lights, and wood and coal stoves and heaters in homes. In the 1880s, Thomas Edison further propelled the development of electrically operated incandescent lamp for reliable commercial indoor lighting along with a generation and distribution system. Edison also mentored Nikola Tesla. Nikola Tesla developed alternating current AC power generation. By the early 20th century, electricity had become the favored method for transmitting energy. Edison established the General Electric, so it's a well-known company till today. So General Electric Research Laboratory for advancement in science and technology. Researchers at GE developed numerous ways electricity can be used. In 1950, nuclear energy emerged as one of the most touted solutions to the world's energy problems. Industrialized nations constructed plants to meet ever multiplying demands for electric power, but not without its drawbacks. Nuclear energy has its drawbacks. Electricity and heat have now become omnipresent and precious commodities. The exploitation of energy resources is on the rise. Engineers are steadily improving the technology so that energy resources could be harnessed in a more effective way. With increase in population, the demand for energy is increasing at a rapid rate. The challenge is to meet this demand in sustainable way. That is, the sustainable way is without disturbing the environment and ecology. Energy is the basic need of life. In these days, 60% of the activities of a human being, this can be checked at a personal level. So 60% of the activities of a human being in a day, they depend on some or the other form of energy, such as light, heat, electricity, chemical, etc. The tendency of majority of human beings all over the world is to work for progress in their life. They strive hard throughout their life to seek material prosperity and luxuries. In life, what are the luxuries in the life? Such as a big home, a better car, modern electronic gadgets, etc. which result into a higher energy consumption per capita. If a higher percentage of population affords these luxuries, then their energy consumption will naturally be higher. Thus, a society or country whose living standard is high consumes more energy per capita. Vice versa, it can be seen that as energy consumption per capita indicates standard of living, vice versa, it can be seen that as energy consumption per capita increases, the standard of living of the citizen in a country thus increases. So it can be seen that energy consumption per capita indicates standard of living of citizens in a country. Thus, the more developed a nation, the more their energy consumption per capita. What is the need now? The fossil energy sources or fossil fuels have become backbones of the economics of the nations globally. However, fossil fuel reserves are finite and are being consumed unscrupulously. In addition, rising population, ever-increasing fuel and power prices, and increasing environmental pollution have jeopardized sustainability of the global sources. So it is high time that an engineer should study the implications of energy, its consumption, and how that is produced. So coming to the basics of energy, let us see the units of energy and power. Unit of energy is joules. The MKS unit of energy is also expressed in the units of calorie. 1 calorie is the heat energy needed to warm 1 gram of water by 1 degree Celsius. So 1 calorie corresponds to 4.2 joules. Watt hour is 1 unit of energy. 1 watt hour is equal to 3600 joules, that is 1 watt, joules per second multiplied by 3600 seconds in an hour. So that comes out to be 3600 joules. So 1 watt hour is 3600 joules. Similarly, 1 kilowatt hour is 1 unit of electricity, that is 3600 kilojoules. Energy unit is also expressed in terms of tons of crude oil equivalent. Every time it is not mentioned that ton of crude oil equivalent, it is conveniently expressed as TOE, tons of oil equivalent. When someone says 1 TOE, it means tons of oil equivalent, which is equal to 42 gigajoules. Another energy unit is British thermal unit. 1 British thermal unit is equal to 1058.5 joules. Unit of power. SI unit of power is watt, which is 1 joules per second. And then MKS unit, a British unit of power, is horsepower. 1 horsepower is equivalent to 746 watt. Energy data of a country, when we talk of a country level energy data, these units or the magnitude is very high. So it is always inconvenient to express those units in joules. So some prefixes are used. Those prefixes are as shown here. Kilojoules, 1 kilojoule is 10 raised to 3 joules. 1 megajoules, which is written as MJ, 1 megajoule is 10 raised to 6 joules. 1 gigajoule is equivalent to 10 raised to 9 joules. When we call TJ, that is 1 terajoule, which is 10 raised to 12 joules. PJ, 1 petajoule is 10 raised to 15 joules. Exa or EJ is 10 raised to 18 joules. Energy sources are classified in many ways. One of the criteria of classification is primary and secondary. Coal, biomass, crude oil, natural gas, biogas, hydro, nuclear, solar, wind, wave, geothermal, and microhydel are the examples of widely consumed energy sources utilized for power generation and process requirements. Energy sources which are extracted from the nature, I repeat, energy sources which are extracted from the nature are called primary sources of energy. Coal, biomass, oil, that is crude oil, natural gas, biogas, hydro, nuclear, solar, wind, wave, geothermal, and microhydel are examples of primary energy sources. These resources are either extracted from the earth or obtainable from the sun. Secondary energy sources are derived from primary sources. Those are heat, electricity, chemical energy, steam, petrol, diesel, and kerosene. These are the examples of secondary energy source. Energy sources can further be classified as commercial and non-commercial. Resources that are traded internationally are called commercial sources of energy. Coal, oil, natural gas, nuclear fuel are commercial sources of energy. These are freely available, non-commercial sources are freely available and they are not internationally traded. So those are called non-commercial sources of energy. Wood in this case has a unique case. Solar, biomass and hydro are non-commercial sources of energy. Wood is traded within a country. We all see that we can purchase a kg of wood from all these shops now. It's available in India. So wood is traded within a country, yet it doesn't become commercial source of energy. Wood is also imported and exported by many countries. However, these import-export transactions of wood are not as a fuel or energy source, but as a commodity. Therefore, wood is not a commercial source of energy. Energy sources that periodically get replenished are termed as renewable. Biomass, solar, and hydro are some examples of renewable sources of energy. Sun we consider as a renewable source of energy, but theoretically speaking, sun is a diminishing star. It is degenerating at an extremely slow rate. So practically we can consider this to be a renewable energy source because sun is estimated to last for billions of years, giving its energy to the earth. So it is a renewable source of energy. World has limited deposits of coal, oil, natural gas and nuclear fuel. So these fuels are therefore termed as non-renewable source of energy. So renewable sources of energy, they are periodically replenished. But non-renewable, they are depletable and finite in source. Another classification of energy sources is conventional and non-conventional. Most of non-renewable energy source technologies are commercially matured and are also termed as conventional sources. So conventional source of energy is that the technology for harnessing that source is commercially established. For example, coal, steam power plants which use coal, it is a commercially mature technology. It is established technology. Oil, DG sets, we get power from DG sets. Transportation, we use transportation using crude oil extracts. So that is a commercially established technology. Natural gas, nuclear. So these resources pertain to conventional sources of energy where the technology is commercially matured. Non-conventional sources of energy are those in which the technology of harnessing is yet to be developed or in a developing stage. For example, solar. Solar, we can use thermal and photovoltaic source. So solar thermal power plants are still in developing stage. They are not. They are available commercial in a commercial age, but the technology is not commercially mature to be uh, popular, we can say. Okay, wind is also a non-conventional source of energy, which is not widely accepted, widely used. Biomass is also a source of energy for the technology for harnessing, like for biomass gasification, for power generation. These technologies are yet to be commercially matured and yet to be accepted. So, with this, we come to the end of session 1, which is energy basics. So the sessions to follow are energy scenario of coal, crude oil and natural gas, and followed by overall scenario and energy security concern. Thank you very much.